This tells us the effect size of the overall study, which we included. That's why you see overall here. The effect size here overall is 0.443, which informs us that moderately there is 0.443, which is positive effect of the intervention which we made on the pregnancy outcome. Remember, the study was on pregnancy outcome. So, for instance, you have the control group and then the treatment group. The treatment group received the intervention. So, it is simply telling us that the intervention provided to the treatment group improved the pregnancy outcome. That is why it's positive 0.443. This is standard error for overall, C-score for overall. This is what tells us that it's statistically significant or not. Because it's less than 0.05, that is the reason why we said that this effect size is moderately positively influencing or having effect on the pregnancy outcome. This is the 95 confidence interval for the overall, lower and upper confidence interval. Then this is for the individual studies. So we have effect size estimate for individual studies. This is the ID for the individual study. 5 studies were included. These are the studies, the authors and the year of publications. And this is the effect size. Effect size for each of these studies, which we include. And then study error for each study. C-score for each study. Some significant level total for each study. This tells us the significant level. And if you see all the studies which we included are less than 0.05 at their significant level, it simply means that they were all statistically significant because they are all less than 0.05. For example, 0.047. And then this is the confidence interval for each study, lower and upper, the weight for each study, and the weight percentage for each study after converting this into 100%. This is test of homogeneity. If you look deeply, you see that on the test of homogeneity, it's not statistically significant. In fact, it's high, 0.997. It's telling us that heterogeneity is low because the homogeneity is high. Now, the heterogeneity measures is also here telling us, confirming what we just said. Because the heterogeneity is low, that's why you see the high squared percent is 0.0. While the H squared is 1.00. It simply means we have low heterogeneity recorded in this study. This is the EGAS regression-based test, which tells us the extent to which the studies that we included, the published studies, have bias. Now, if we look at this, you see that they are not statistically significant. The intercept here is not statistically significant. The standard error is not also statistically significant. Because they are not statistically significant, it tells us that the studies which we included in our analysis are not biased. There is no selection bias in the process. So this is the 95 confidence interval for low and upper for each of them. And this is the trim and fill analysis summary. So if you look at this, effect size estimate for trim and fill analysis tells us the observed and the observed plus imputed. Here we have number of imputed studies, just one, telling us that it's only one imputed study that the analysis which we use, the software which we use, was able to reshape our 5 studies to give us 6 here, implying that it trims and also fill the analysis to ensure that the study is appropriate and consistently giving the results. That is why I say this, there is a slight difference on the effect size between the observed, which is 0.443 and 0.432. So if you see the difference is just very slight difference. So which means that there is no large differences or effect between the mean or the effect size of the observed real study which we included and the imputed study which the analysis or the software inputted to ensure that it trims and fills the analysis appropriately. And they are all statistically significant, less than 0.01 to each of them, which tells us that there is no much difference between the observed and the imputed. So this is our forest plot which we ran. If you look well, you're going to see our ID for this study, and then you also see the study authors and the years here. And the Cohensd, this Cohensd, remember, it stands for effect size, overall effect size for each particular study or for overall study. So this is the Cohensd effect size for overall study, which is 0.44. The same thing, if you look at the forest plot here, you also see 0.44, indicating the same overall effect size. While this is for each study, the Cohensd effect size for each study is what we have here. For GEMS 2024, for example, you have 0.50. And then these are standard error for each study, which we explained, the lower and the upper for each study. The p-value for each study, they were all statistically significant because they are all less than 0.05. Then this is the weight for each study, and this is the weight percent for each study, which we recorded and explained earlier. This is just this other part, which is pictorial. Forest plot is just a presentation of this, what we have here in a pictorial form. Now, if you also look at this, they all have differences. So you see there are some blue boxes here. This box here, each of these boxes represents the effect size of each study. So example, study GEMS 2024 study is this box. Why? The one for EMAS 2025 is this box. And if you look deeply, you notice that the blue boxes, some are larger than some. The determination of this largeness is because of the weight of the study. So for example, this one that has a small box, small blue box, the weight is 15.65 and the weight percent is 14.36. But for the large one, here, which is EMAS, you're going to see the weight is 23.13 and the weight percent is 21.23. You see, the weight here is larger. That is why you see the box is larger. Then also, you have to take note of this, that we also have what is called this line here. We are seeing horizontal line here represent the confidence interval of each effect size, or confidence interval for each effect size for study. Now, but if you want to see for overall, this other horizontal line here is for the overall effect size. Then, if you look at what you're going to see, there is also a straight line here, which you have here. This 0.442, this dotted line is overall effect size value. That is why we have here overall effect size, which is similar to saying log odd. If at all it was binary analysis, where we have 0.442 here, for example, which is moderately significant. Now, then another thing you need to understand is that all the studies were significant. That is why you did not see the null line effect shown. That means none of these studies crosses 1. They are all statistically significant. So in addition to that, you guys are going to see the same thing here. This particular purple or reddish color here also stands for the overall effect size of the 0.44 to which we have here. Then this is the funnel plot indicating a random effect model which we have run. And take note that each of these one year, this Mohammed, for example, 2023, this circle blue line here indicate primary studies which we included. Each study represent each study. And if you look deeply, you are going to also notice that you have here the vertical line here. This vertical line here is estimated effect of the overall effect size of the studies observed, the studies we included. So if you look at it, you're going to see the estimated overall effect size here. This vertical line is moving towards 0.44. So it's telling us the same 0.44 which we had here, this part. So this is this particular aspect, the standard error here is the area that talks about the y-axis, while the x-axis is the Cohensd, referring to the effect sizes. Then you may also wonder, why do we have this other triangular shape with dotted line? This triangular shape of dotted line refers to the 95% pseudo confidence interval. This, and you also look carefully, you notice that all the studies which we included are distributed symmetrically within this confidence interval. That's why I say they are within. They are not, none of them is outside. Now, this is how you run the analysis. Continuous outcome, the meta-analysis using SPSS. Then also, if you may want to say, how do I report this? If you are confused of how to report it, you may decide to say, okay, for example, you can take this as sample. So yes, state interpretation for reporting. You may want to say, for instance, that this meta-analysis of 5 studies using continuous outcome measures reveal a statistically significant and moderate positive effect of the intervention with a pool Cohensd of 0.443, which is what we have here, 0.443 Cohensd. Or you can also go and see here, overall 0.44. What do you mean? The confidence interval which we have is the same confidence interval, and then give us the, and the p-value here less than 0.001, which we have here. Then all included studies individually show significant effect. There was no observed heterogeneity. That is why our heterogeneity, if you look well, deeply, was what we have here. See, there was no observed heterogeneity, which is equals to 0%. This 0% which we have here. Suggesting consistent finding across studies. Publication bias analysis, which we did using ICAS test and trim and fail, confirmed the robustness of the result, meaning that there was no publication bias analysis in our study. For our forest plot, we feel that all 5 studies reported a positive and statistically significant effect, which we did. They all reported on the forest plot, they all reported statistically significant. This is the row for it. Now, the funnel plot shows a symmetric distribution of the study around the pool effect size, which we did. They all distribute around the pool effect size. That all of the 5 studies reported positive and statistically significant effect. Then the funnel plot shows a symmetric distribution of the studies around the pool effect size line, indicating low risk of publication bias. These findings support the effectiveness of the intervention in improving the study pregnancy-related outcome, because the study was in relation to pregnancy. So thank you very much for watching.